Hello and welcome to this particular session which is related to model based development, and it is also called as MBD, which is a very important in the automotive software field. Okay, so here we will discuss about the introduction part. What is model based development or MBD? So model based development means creating and testing the software using models instead of writing everything directly in a coding languages. So in a simple words, we use block diagram and simulations tool like MATLAB and Simulink to design, test and check the system behavior and making them final code. Okay, so instead of writing thousands of lines of codes, first we make a visual model to understand the working of the system. So now why MBD is used in the automotive softwares, or why companies are shifting toward model based development. Okay, so if we talk about the vehicles, so in vehicles software is becoming more complex because we have advanced features like electronic power steering, engine control, then ABS, which is anti-lock braking system, then autonomous driving and infotainment. Okay, so writing code directly for all these features take a too much time and it will create some mistakes also. Okay, so that is why companies are using a model based development. Okay, they are focusing on this model based development, so it helps to design systems very quickly and to test them easily way and then generate a error free codes. Now, differences between traditional codes and the MBD. So in the traditional method, software engineers write logics using programming languages like C by lines. Okay, then they will testing become a difficult and many times error are found. Okay, in the later period. Okay, so in the MBD, engineers create the software using a block and the models in the Simulink or similar tools. So these blocks are tested early by the simulations. Okay, and code is auto generated from the model, so it saves time and reduce errors compared to the manual codings. So now let's talk about the benefit of MBD. So the first one is your faster design. So the development becomes quick because models are easily to make and test. Then errors will be less. Okay, so models are tested step by steps, so mistakes are very less, or we can say it is very few errors. Now third one is better testing. We can simulate many real world simulations before coding for hardware. And the fourth one is easy changes. Okay, if the requirement changes, for example, if companies changes the requirement based on the uh, norms related to emission norms and other norms. Okay, so we can quickly modify the model instead of editing the big programs if that program is related to particular emissions. Okay, now let's take one example. So we have one example like cruise control system. So think about this cruise control in a car. So normally if we use traditional code, we would need to write a long C code to maintain a vehicle speed at a set value. So this would take more time and chance of error, and these chances of error will be high. Okay, but with MBD model based development, we can use Simulink block to design the same cruise control, and we just need to connect blocks for the input like accelerator pedal, processing the logics like controlling the throttle, and the output vehicle speed. So we can run the simulations to check how the control system work and also test it for the different road conditions. So after this testing, the software can auto generate C codes directly from the Simulink model, so the development can become very fast and safe. So here you can see one side I have just added one small logic related to cruise control, and another side the code which is generated from this particular control system. Okay, so you can compare which process is very easy, writing a code or creating a model by using a Simulink. Okay, so this was the introductions to model based development, and it's needed in the automotive software. and its benefits and examples of cruise control. So in the next video, we will explore some more topics related to model based development. So thank you for watching. Hello and welcome back. In this session, we will learn about the MATLAB scripting, which is also called as M files. And we will see a small demo of how to do calculations and plotting in the MATLAB. So first of all, what is MATLAB scripting or M files? So the MATLAB scripting means writing a set of commands in the file so that we can run them together as a program. And these files are saved with the extension .m, and that is why they are called M files. So instead of typing every command in the MATLAB command window again and again, we can just write them inside a script and we can run it whenever we want. Okay. So writing a small script. So a script is like a simple program. It can have a variable definitions, calculations, commands for plotting, and by running the script, MATLAB will execute the everything step by steps. So this is your MATLAB window. So in this particular window, you can see command window is there. Then after current folder, so here it is your current structure like folder path. Okay, whatever you will do, it will be saved in your current folder path. Okay, so this is the workspace. So whatever you will give the command, it will be stored in the workspace. Okay, and this is the command history. Okay, so we are discussing about the variables. So defining the variables. So in the MATLAB, we do not need to declare data type separately like in the C. We can directly assign values. For example, here I'm typing A equals to 10. Okay, semicolon, enter. Then B equals to 5, semicolon, enter. So here you can see A and B are the variables. A and B are the variables which is stored in your workspace. Now, based on this particular variables, we will do one simple calculation. So, and here just what I have to do, I will just open a new script, and in this script window, I will just type sum equals to A plus B. Okay, so before that I need to assign that particular values in this particular uh, script file. Okay, so enter. Here you just type whatever we have written in this command window. For example, okay, this things I will just add in the script file. Okay, now another one is I have to do difference. Okay, subtraction I will do. So diff equals to A minus B. Okay, these things you can do directly in your command window also. Okay, but for your better understanding, I will just writing in this particular file, scripting file also. Okay, so that I can save this file and I can reuse it again and again whenever I want. Now product, okay, equals to A into B. Okay, just save this file like basic underscore arithmetic. Okay, close this and clear workspace, clear command window, clear history. So these things you can do by CLCs, clear all. There is short commands are also available. So for that you can use. Okay, these all are the inbuilt command like CLC. Same thing is there. Clear all, clear all. So this type of command also you can use to clean this particular Windows command window workspace. Okay. Now just I will run this code. Run. Okay, here the mistake was there. Instead of plus, it is equals to CLC and clear all. Okay, now run. So here you can see with that particular script, we got some output results like sum of a plus b. Here you can see it is giving 15. Then after product also a into b, it is giving as a 50. 5 into 10 equals to 50. Then difference also we got like 10 minus 5 equals to 5. So this is very easy to solve any big arithmetic operations, okay, by using this particular MATLAB command window or by using scripting. Okay. Now here we will see one example related to uh, plotting the results. Okay, so just start with a new script and first we will save this file. So save the file like plot underscore vehicle. Okay, now in this particular script file I will write one small code. Okay, so t equals to, so first of all, this MATLAB is very powerful tool for plotting such type of graphs, okay, and to analyze the results. Okay, so here I will just continue with my code. So t equals to 0 colon 0 0.1, then 10. Okay, so two things I want to clear here. So for example, if you will not add this particular semicolon, so what will happen? It will print the results like t. So in the command window, you will see the t results. Okay, so better and good practice is what, after completing the line of code, you just add semicolon. So if you don't want to print the results, okay, in your command window or in the workspace. Okay, and one more thing, for example, if you have to add some comment related to this particular line, so how you will add the comment? So you just add a percentage, okay, and you give a time. Okay, means this is comment you have added, this particular line is related to your time. So that things you can add by using this percentage symbol. Okay, now come to the coding. Speed equals to 20 plus 2 into t, again semicolon, enter. Now plot t comma speed, bracket close, semicolon, enter. Okay, x label, bracket start, then time. Okay, now y label, kilometer per hour. Okay, save this file and just before proceeding to run this script, I will just explain. Okay, so here in this script, t is your, it is the time for 0 to 10 second. Okay, so this is 0 to 10 second, we are adding time for 0 to 10 second. Speed is increasing with the time starting from 20 kilometer per hour and adding 2 kilometer per hour in every 2 second. Okay, so the plot function shows how the speed changes with the time. So let's run this particular script. So this is the simple graph, explains that as the time goes on, the speed of the vehicle is gradually increasing. Okay, now here in this workspace, you all can see there is no output is coming, like because I have added this particular semicolon. Now if you will not add, so I will show you the demo. Like suppose I have deleted from here also. Let's run, save this file and again run. Now in this command window, you can see it is printing the result like time value and speed value. Okay, so to avoid these things, you can just add semicolon. Okay, done. Now just here in the command window, you just clear all these things. Clear, clear all, and CLC. Okay, and now run. So see, it is clean. You will not see any output from this particular time and speed. Okay, so this is the very basic introductions to MATLAB scripting. So how to define the variables in the MATLAB command window, or doing the calculations and making a simple plots. So in the next session we will connect this block basics with the automotive applications using a Simulink. So thank you for watching. Hello and welcome to this session. So in this particular session, we will discuss about the basics of Simulink. So which is the one of the most important tool used in the automotive industry for controlling system design and the testing. So what is Simulink? So basically a Simulink is a graphical tool that work along with the MATLAB. So instead of writing code in the Simulink, we build the models by connecting blocks, and these blocks represent the functions, equations or operations, and it is very useful for control system, signal processing and automotive software development because it allows us to design, simulate and test the systems step by step. So in the Simulink, we represents a control system as a block diagram. So okay, so each block does one job like multiplying, adding or integrating. Okay, so by connecting these blocks, we can show the flow of informations from input to the output, as you can see in this particular examples. Like here I have added a addition, then after multiplication and integrations. Okay, so this visual method makes even complex system easy to understand, test and explain. So now let's see a signal flow between the blocks. So in the Simulink, signals flow through line that connect the blocks. For example, an input signal goes through a controller block and then the output goes to the plant for the system block. Okay, so we can observe how the signal changes as it passes through different blocks in the diagram. Now let's discuss about some common blocks used in the automotive. Okay, so some blocks are very useful in the automotive applications like your gain block, integrator block, switch block and lookup table blocks. Okay, so first, what is gain block? So this is a multiplies the signals with a constant number, for example applying a proportional control. Another one is your integrator block. So uses of this particular integrator block to get the output, for example converting acceleration to the speed or speed to the distance. Now the switch block, so switch block is used to choose between different inputs depending on a conditions, for example selecting a manual or a cruise control mode. Now the last one is your lookup table block. So it is stores the predefined values and gives the output based on the input. Okay, so examples like engine map that tell fuel injection based on the speed and load. So in the MATLAB Simulink window, you can see there are many blocks used. Okay, so based on your requirement, you can use from them. Okay. Hello everyone, welcome to this video class, and today you will learn how to make your first Simulink model, okay, by using a Simulink. Okay, and this is basically a model for a vehicle velocity, and we will use a very basic example so everyone understand it very clearly. So what are we modeling? So basically we want to model how fast a vehicle goes by using this particular formula, which is m into dv by dt equals to f minus r, where m is the mass of the car. So let's say 2000 kg. F is the driving force, for example for the engine or the motor. R is the resistance, which can include your air drag or a frictions, and the answer or the output is the velocity, which is v bracket t, okay, and which means speed of the car at every time. So let us use simple values to make it easy. Suppose the engine force F equals to 2000 newtons and resistance is your 500 newtons, okay. So the mass is equals to 1000 kg. So acceleration is your 2000 minus 500 divided by 1000 equals to 1.5 meter per second square. And if we keep this for a 20 seconds, the speed will be 1.5 minus 20 into 30 meter per second, or around 108 kilometers per hour. Okay, now we will model this small model by using a Simulink. So now here we will start with the Simulink modeling. Okay, so modeling of that basic simple model. Okay, so basically here we will use a simple blocks. So for that we need to open a Simulink window. So you can directly come here new and select the Simulink model, or else you simply type here Simulink and enter button. So it will open a new start page. From here you can just select create model. Okay, so this empty canva will be open. So before starting any model you need to save first of all. So save, select the first underscore model. Okay, so this is saved. Now here we will use a very basic simple blocks. So first I will open constant. So type here constant. Okay, now next thing is what we need to copy this block. Okay, so I will add 2 times constant block here. Come to format, I want to show some hidden names so you can see the names. Okay, now the first block is your force. So what you can type here, force. Okay, another block is your resistance, which is R. Okay, now next thing is what we need to do, F minus R means force minus resistance. So for that I will add a sum block. So sum block, just double click on this sum block and change from round to rectangle, and here plus minus because F minus R we need to do, and just okay, now done. Now here we need to connect some lines. Okay, connections we need to do. So for that connection you just select this force or constant block, and with this constant, sorry, with this sum block by using control button. Okay, so automatically it will create a line. Another method is what, just simply select this force output to this input. Okay, now the next method is what, just you drag this one and you will see light blue color line is there. So just click on this line, you will automatically it will connect with this particular block. Okay, so like this you can do connections. Now next thing is what, we need to calculate the mass. So we need to add some mass here. Okay, so for that what you will do, you will just type here gain block. So I will add gain and connect this one. Now we need to integrate to get the velocity. So for that I will use integrator block. Integrator block. Done. Now select this one and we need to display some results. So for displaying result we will use display block, and for visualization we will use a scope. And connect this one. That's all. Now here we need to save this model first of all. Okay, so model is saved at this phase. Now we need to change this stop time to 20 second. Done. Again we will go to MATLAB command window because we need to define this variables force, resistance and mass. Okay, so for that what I will do, I will just come back to the command window and here I will type F, which is your force, equals to 2000 Newton R equals to resistance, which is your 500, and mass small m equals to 1000. So here you can see in your workspace all the variables are present with their respective values. Okay, now again I will come back to the Simulink window, and here just type F. So you will see the value whatever we have written in the workspace related to force, it is coming here. Okay, 2000. No need to add manually here. So this is very good practice whenever you are using a big models. During that time, this kind of activity is useful, because suppose you need to add resistance in so many places if you are using a big model. So instead of writing manually, simply you can define in your workspace, and directly it will fetch the details from there. Okay, so here I will just add R. So here you can see 500 is coming automatically. Apply. Okay, now for the gain we need to divide by m. So divide by m. Okay, so take the m value, apply. Okay, so this model is created. Now we will save this one once again, and using some basic configuration settings, no need to change, we will run this model. Okay, so here you can see the result 30, and 30 is your 30 meter per second, or if you convert into kilometer it will be your 108 kilometer per hour. And in scope you can see the results of a graph. Okay, so let's double click, and you can see the result. So you can customize this also by going to the style, and if you want to change the background color and all, you can simply select and you can change like this. Black, apply. Here you can change to red. Dimension also you can change. Okay, so this is active display is only one, so it is showing as a one. Okay, so like this. So this was the introductions to Simulink basic. So the idea of the block diagram, signal flow, and the common blocks, and a small demo of your Simulink modeling, how we can model logic in the Simulink. Okay, so thank you for watching this particular session. Hello everyone, welcome to this session. Now till now we have understand the MATLAB scripting and Simulink basics. So now let's understand the some actual workflow of the model based development in the automotive industry. So here we will see the basic steps. Okay, what are the steps followed in the MBD model based development workflow in any automotive industry. So the first step is define the system requirement. So in this step every project starts with a clear requirement. So for example, you are working on some model, let's say cruise control model. So in that you got some requirement that you have to maintain the 80 kilometer per hour vehicle speed. Okay, so this requirement becomes the base for particular design. Now the second step is create the test input with the MATLAB script. So in this step, we use MATLAB scripting to prepare test cases such as different road slope, driver inputs, or speed value. So this help to test how the system will behave under the multiple conditions. Now the third step is building a controller model in the Simulink. So in this step, we design the controller block in the Simulink. For example, cruise control. So this may include error calculations, a proportional plus integral controller, and a plant model of the vehicle. So in the step 4, it is related to the run the simulation and checks the result. So in this step particularly, once the model is ready, we run the simulations. Okay, and the scope or plot will show if the vehicle speed is maintained near 80 km per hour or not. If results are not good, engineers can tune the controller and quickly rerun the simulations again. Okay, and again they will check whether it is maintaining that particular criteria or not, which is 80 km per hour. Now the fifth step is what? It is for generate C code automatically. So after the models work properly, we use embedded coder to generate C code directly from the Simulink model. So this step reduces the human error compared to manual coding and saves a lot of development time. And the sixth step is deploy on ECU for vehicle tests. So the generated C code is then flashed into the ECU of the vehicle. And finally, the system is tested in the real driving conditions to confirm that cruise control maintain the required step. Okay, speed. So this was the complete workflow of model-based development in automotive software development. Okay, for requirement to the ECU testing. Okay, so in the next session we will look into some testing validations and how MBD ensures safety and reliability in the vehicles. So thank you for watching. Hello everyone, welcome back. So in this session we will discuss the different types of testing in the model based development, and we will see some important applications in the automotive industry. So the first we will see the types of testing in MBD. The first one is model in loop, which is also known as mill testing. Okay, so in this stage we test the control logic inside the Simulink model itself. So the focus is to check if the model works as per the requirement before generating any code. For example, testing cruise control logic in the Simulink by simulation. Another one is your software in the loop, which is also known as SIL testing. Okay, so here the model is converted into C code and then the code is tested on the computer. So this helps us check whether the auto generated code behaves the same as the Simulink model. Okay, so SIL ensures model and the code matches correctly. So the third one is your hardware in the loop. So in this stage the generated code is loaded into the ECU hardware and the ECU is tested in the lab environment by giving its real-time inputs using simulations tool. And hill testing saves the time and the cost by checking the ECU's functions without testing on the real vehicle. Okay, so now here we will see some automotive applications of MBD. Okay, so the first one is your engine management system. So MBD is used for fuel injections, ignition timing and emission control. And the second one is your battery management in the electric vehicle, which is used to monitor the cell voltage, current and the temperature for safe operations. Okay, the third one is your ABS and the cruise control. So it will use to control the wheels, braking and maintain the constant speed through the controller designed in the Simulink. And the last one is your ADAS functions. So basically ADAS driver assist features like lane keeping, collision warning and adaptive cruise control are developed and tested with the MBD to ensure the safety. So this was about the different types of testing in the model based development, which is your mill, sill and hill. Apart from this, we have one more testing, which is pill, basically known as processor in the loop. Okay, and we have also discussed some key applications in the automotive systems like engine management, battery management, ABS cruise control and the ADAS. So now let's quickly summarize what we learned in this series on model based development. So model based development or MBD has become a very important approach in the automotive industry because it saves both time and reduce the errors in the ECU development. So with the MATLAB scripting, we can easily prepare the test data, perform the calculations and analyze the results step by steps. And with the Simulink, we can design visual block models and run the simulations and the test the control logic very quickly. So when MATLAB and Simulink both are used together, they make a very powerful toolkit for the engineers, and they help in the faster design, early testing, automatic code generations and development of the ECU. That is why MBD is a key method in the modern automotive software development, especially for the electric vehicles, ADAS and the future software defined vehicles. So thank you for watching this particular series on model based development, and please keep exploring MATLAB and Simulink so that you will see how model based development is shaping the future of the automotive world. So thank you so much once again.